Again, I thought this one was one I probably wanted to walk you through. It is tough enough. I hope you see, oh, this is, boy, wouldn't this just be nice if this was just e to the u du that we had to integrate? So that's where we're headed. I want to make it be that. So what you got to remember is, well, let's see. I mean, you've done a few of these. If you did the book, you did a book work, you did a bit more than that. But what if we say u equals arc sine of x? And well, you take the derivative of that. Now you might have a formula written down somewhere, or let's see, what is it? One minus x squared dx. Now, how do I honestly don't really remember that. So I'm going to do it. I'm going to do this like we did back in chapter 4, or maybe even chapter 3, with the derivatives of inverse trig functions. So I'm going to say if u equals the arc sine of x, doesn't the sine of angle u equal x? And that's, of course, that's x over 1. So let's see, x over 1, so that becomes the square root of 1 minus x squared. So you're starting to see where that's all coming from, right? So if we do the derivative, that's going to be what? Cosine u equals dx, 1 dx, right? And so we're going to divide by, or we're going to divide, oh, I'm sorry, I forgot to have the du dx here. And then chain rule, implicit differentiation. So then I'm going to divide by cosine u, which is the same thing as secant u, right? So the derivative, so the du dx equals the secant of u times dx. Well, I guess I could say I don't need the dx really because I get it over there. But let's leave it there. And so the secant will be the adjacent hypotenuse over the adjacent, right? So 1 over the square root of 1 minus x squared, which is that's what we have here. So, I mean, you can memorize the formula, or you can just do this each time. And after a while, it becomes very fast. Okay, so now let's get back to the integration process in this problem. Here, let me clean up some space here. So I've done, I hope you see now that we've got, I've got the e to the u, so I've got the e to the u, and then I have the dx and the 1 over 1 minus x squared. So this all can be replaced with what my desired outcome was, e to the u du, and we know what's the antiderivative of e to the u, e to the anything? Well, itself. And of course, then we know that u is this arc sine, so the arc sine of x, plus a constant, and you'll see that's what the answer was. Okay, so that's a pretty cool substitution.